So for part B of question 10, we need to integrate by parts. Now it doesn't seem to have any parts, so let's put a 1 times square root a squared minus x squared dx, and we can integrate that 1. When we integrate that 1, we get x. We leave the a squared minus x squared there, minus the integral of, we did the x. Now the derivative of, so let's just think of this, the derivative of a squared minus x squared to the power of a half, it's easier to think of that way. So the half comes in front, we've got a squared minus x squared minus 1 from the power and times by the derivative of the inside, so minus 2x. So you can see that would be minus x on square root a squared minus x squared. So that is the derivative we're going to put in. So minus x on square root a squared minus x squared dx. So I'm going to rub that bit out, but it is easier just to do that separately. So we've got our x square root a squared minus x squared part minus. So here we've really got a minus, which is a positive. But we've got the x squared there, or we can keep that minus. We can have minus x squared there, which is nice because the denominator has a minus x squared. But if we do that, we want to add an a squared in. If I add an a squared in, it's now a squared minus x squared on square root of a squared minus x squared dx. So I'm going to have to subtract, or in this case it's a minus a squared, so I'm going to add an a squared. So remember, a squared is just a constant. So just to balance it up, I'm going to do that. All right, so still we've got our x square root. Sorry about this writing. Need to fix this pen. All right, so here we've got the integral of, so we've got 1 on top and a half on the bottom. 1 minus half is a half, so a squared minus x squared to the power of a half dx there. Plus here we've got a squared. Now this is just an inverse sine, so that's a nice one, x on a. All right, so you can see that this is the exact same. So this one here is the same integral we started with. So if we add it to the other side, we've now got 2 lots of that integral. And we still have this one over here. And we still have this one. So the answer then to this would be if we divided everything by 2, so we're going to have x on 2, square root a squared minus x squared, plus a squared on 2, inverse sine x on a, make sure that's an inverse sine x on a, and don't forget, yeah, I should put a plus c in there. So if I use a plus c here, I could do a d here.